Light travels at 186,000 miles per second. But do you have any idea how strange that number really is? The universe is 13.7 billion years old. Countless stars have exploded in that time. Countless black holes have devoured everything. And the speed of light has never changed, not by a nanometer per second. It's downright unbelievable. It's as if someone at the moment of the Big Bang carved this number into the very bedrock of physical law. In 2003, scientists found that if light were just 1% faster, protons would fly apart. 1% slower in nuclear fusion inside stars would never ignite. The entire cosmos would freeze into eternal silence. What this means is the margin of error for lightspeed is zero, not close to zero, but absolutely zero. In 2012, CERN conducted an experiment. They accelerated protons to 99.9999991% of lightspeed. But to go that last 0.0000001% faster would require enough energy to blow the entire planet to bits. Scientists have calculated to accelerate an apple to the speed of light would take all the electricity humanity generates in a year. But the universe is brutally clear. It dangles the prize in front of you, lets you see it but never lets you reach it. So the question is, why is this number so precise and so unchangeable? Could it really just be a coincidence? The answer might shock you more than you think. In 1905, a 26-year-old Albert Einstein was working at the Swiss Patent Office. He was pondering a question. What would I see if I wrote a beam of light? That seemingly simple question shattered everything we thought we knew about time and space. No matter how fast you chase after a beam of light, he found it always races away from you at 186,000 miles per second. It never slows down, not one bit. What does that mean? It means time and space aren't fixed. They warp and bend depending on how fast you're moving. When Einstein put that conclusion on paper, the physics world was rocked. It toppled Newton's entire classical universe. Even wilder is time dilation. In 1971, two American physicists ran an experiment. They synchronized two atomic clocks perfectly, left one on the ground, and flew the other around the world on a jet. When the plane landed, they were stunned. The flown clock was 59 nanoseconds slower than the one on the ground. 59 nanoseconds sounds tiny, but it proved a critical fact. The faster you move, the slower time passes. Scientists have worked it out. If you took a spaceship traveling at 99% of light speed for 1 year, 7 years would pass back on Earth. Meaning when you returned home, your friends, your family, the entire world would be 6 years older than you. You'd think you just took a space trip, but time left you behind. At 99.9% of light speed, the effect becomes staggering. 1 year for you on the ship is 22 years on Earth. At 99.99% Earth sees 70 years pass. Hit 99.999% and 223 years go by back home. See, the universe is that cold it uses time itself to cut you off from your entire civilization. But that's not even the most crushing part. The real kicker: scientists found that as an object accelerates, its mass increases. That's right, a 1 kilogram metal ball traveling at 90% of light speed weighs 2.3 kilograms. At 99% it's 7 kilograms. At 99.9% it balloons to 22 kilograms. And as it gets infinitely close to light speed, its mass shoots toward infinity. What's infinity mean? It means even if you used all the energy in the cosmos, you couldn't make it go 1 bit faster. That's the heart of the lightspeed limit. It's not a wall you can break through. It's an absolute law woven into physics itself. CERN's 17-mile-long Large Hadron Collider exists to smash protons. They can get protons up to 99.9999991% of lightspeed, using enough power for a small city for a year. But even with 100 times more energy, a proton speed might only creep from 99.9999991 to 99.9999992%, always that last tiny bit out of reach. In 2011, scientists observed something even weirder. As a proton nears lightspeed, the spacetime around it warps, forming a kind of transparent cocoon. Any force trying to push it faster just gets absorbed by this cocoon. It's like the universe is saying this far, no farther. So why would the universe set this limit? Scientists have a mind-bending answer: causality. If something could go faster than light, it could theoretically go back in time. Imagine firing a superluminal missile. It could hit its target before you even fired it. The effect would happen before the cause. The whole chain of logic would snap. You could go back and kill your own grandfather. But if your grandfather dies, you were never born, so who went back to kill him? That paradox would tear reality apart. Therefore, the lightspeed limit might be the universe's final firewall protecting cause and effect itself. Break it, and the entire logical framework of the cosmos collapses. But there's a deeper layer of despair. Even if you had a lightspeed ship, you'd find light is agonizingly slow on the cosmic scale. The Milky Way is 100,000 light-years across. Traveling from Earth to the galactic edge at light speed would take 50,000 years. A human lifetime is barely a century. You wouldn't even leave our solar system before your life ended. Even if time didn't matter, a lightspeed ship can't change another brutal fact. In 1998, scientists discovered the universe is expanding faster and faster. Galaxies over 14 billion light-years away are already moving away from us faster than light. So even if you left at lightspeed today, you could never catch them. They'd vanish from your view forever. Astronomers have calculated that limited by lightspeed, humanity could only ever reach a cosmic bubble about 16 billion light-years in radius. The observable universe is 46.5 billion light-years across, which means over 30 billion light-years of it we can never ever touch. We are trapped forever inside a 16-billion light-year cosmic prison. Those distant galaxies, those magnificent sights, we can only ever watch them, never reach them. The universe is a gilded cage. Lightspeed is the bars. Cosmic expansion is the warden, and humanity might just be prisoners serving a life sentence. Worse, as the universe keeps accelerating, this prison is actually shrinking. Every billion years, more galaxies cross the lightspeed horizon and are lost to us forever. Gone for good. In 100 billion years, beyond the Milky Way and a handful of neighbors, the entire observable sky will go pitch black. Future humans looking up might see nothing but empty void. Is there truly no way out? Scientists have proposed some theoretical loopholes. The first is wormholes. According to general relativity, spacetime can be twisted so extremely it forms a tunnel connecting two distant points. Find or create a stable wormhole, and you skip the distance, arriving instantly. This doesn't break the lightspeed rule, because you're not moving faster than light through space, you're just taking a shortcut. But the catch: keeping a wormhole open requires exotic matter with negative energy, and we've never seen a single speck of such stuff. The second possibility is a warp drive. In 1994, physicist Miguel Alcubierre proposed a wild idea. Contract space in front of a ship, expand space behind it. The ship sits still inside a motionless warp bubble. That way, the ship relative to its bubble doesn't move. No lightspeed violation, but the bubble itself can move faster than light relative to outside space. It sounds perfect, but the negative energy needed to make it work is about the mass of Jupiter. We can barely make a single gram of antimatter, let alone a Jupiter's worth of exotic energy. So the hard truth might be this: the lightspeed limit is an unbreakable ultimate law. The universe 13.7 billion years ago wrote this number into the deepest layer of physical law. Any attempt to break it gets crushed by physics itself. Time slows to a crawl, mass skyrockets, energy drains away, causality unravels, and those distant stars, those breathtaking cosmic vistas, will only ever exist in our telescopes. We can never truly touch them. That's the cruelest part of the lightspeed limit. It's not saying you're not fast enough, it's declaring that no matter how fast you run, you're destined to never catch up. But maybe that's the design. The universe gave us eyes to see the starry ocean, then used lightspeed to lock us in this tiny corner. It showed us infinite possibilities, then whispered through the laws of physics, look but don't touch. Maybe in some distant corner of the cosmos, there are advanced civilizations laughing at our dilemma, long past such primitive limits. Or maybe every civilization in the universe is trapped by this same barrier, struggling in the same cage, and the speed of light might just be the eternal stamp the Creator placed on all intelligent life at the dawn of time.